Hi, in this video, I'm gonna go through the principles of experiment design or experimental design with an example of a test answer as in a intro to statistics course. This video is not about designing an apparatus to do, say, something like a chemistry experiment. No, this is for a statistics class. Let's take an example. Suppose we want to find out, does vapor up or bakuru in some pronunciation relieve stomachache? Can you tell what the variables are? Well, in this research question, we're researching whether vapor up use leads to stomachache relief. So those two things are our variables. Specifically, vapor up use is the explanatory variable and stomachache relief is the response variable. The way you figure this out is to think like this. Suppose it works. Yeah, suppose vapor up relieves stomachache. Then when you put vapor up on, the body responds and the stomachache gets better. So stomachache relief is the response variable. And vice versa, if you had stomachache before and now you no longer have it, your friend says, wow, how come you no longer have stomachache? And you say, because vapor up. Your friend wants an explanation and you say it's vapor up. So vapor up is the explanatory variable. That means as soon as we have the research question, we should be able to identify the explanatory variables and the response variables. I have the S in parentheses because sometimes in a research question, we may have many explanatory variables and we may also have many response variables. What it means is that if you write the research question and you look at it and you still cannot tell what the explanatory variables and the response variables are, try to rephrase it. Rephrase it so that you can say it like certain things lead to certain other things. Then you can tell the explanatory variables from the response variables. All right, we have our research question. How would we test this? How would we test whether vapor up use leads to stomachache relief? Well, your first instinct would probably tell you we should get a bunch of people together who have stomach aches, and then we give them vapor up and see what happens. That should be your first instinct and good idea. Let's get started. Let's find a bunch of people with stomachache. Ideally, we would like to find all the people with stomachache in the entire universe. That would be our population or population of interest. Well, in reality, we probably can't do that. First of all, we probably don't have the money. Second of all, we probably can't even find them. And even if we do find them, third of all, we probably don't have enough vapor up to just give everyone some to try. Yeah, doing it to all people with stomachache is not possible. What we do instead is to find a smaller group of people, a subset of the population, and we work with them. That's called a sample. A sample is a subset of the population that we will work with. The process of selecting out who in the population is in your sample is called sampling. And a good sample should be representative of the population. The good sample should look like the population. And there are two things you need to do to ensure that your sample is representative of the population. One of it is large sample size. In general, a large sample is better than a small sample. In general, all else being equal. A large sample size, when you have a large group of people, you have a better chance of having different kinds of people in it, right? But you also know that sometimes a large group is just the whole group is like all of the same age and all the same level of health and all ate the same thing yesterday, right? So large sample size is a good thing, and we want it almost all the time, but it's never enough by itself. The thing that people have identified that makes for a good sample is randomness. Randomness in statistics means something very specific mathematically. It means every person in the population has an equal chance of being in your sample. It does not mean the same as randomness as used in everyday life. I have a video about it, so check out the link above. When you have randomness in selecting out your sample, that's called random selection. You want random selection. Right, so you have our sample. We have a bunch of people with stomachache. We're going to give them vapor up and see what happens. Well, suppose that 70% of them got better. Well, that looks really good for vapor up, doesn't it? But maybe not. What if 70% of people would have gotten better anyway? What if doing nothing, you wait a couple days and the stomachache will be gone by itself? If that's the case, then vapor up is getting credit for something it didn't do, now would it? Therefore, we need to have a way of figuring out what would happen if we do nothing. That's called control. We need a group without vapor up so we can establish a control. Some people call it a baseline. If left alone, let's say 70% of the people get better, then that means vapor up didn't do anything. But if left alone, only 35% of the people get better, then we know that, yeah, vapor up helped. It pushed the number from 35% all the way up to 70%. Yeah, we need a group without vapor up, and that's called control. But having a group with nothing is not enough. There's a thing called placebo effect. The placebo effect is the phenomenon that the fact that we're doing something with these people by itself may affect the result. The fact that a nurse or a pharmacist or a doctor hands them a jar of vapor up and tells them to use it, that by itself may boost their confidence or something, and they feel better about the stomachache. Therefore, we need to replace the do nothing with do something, but not vapor up, right? So that's a placebo. Therefore, we need two treatments. One treatment is a placebo that represents kind of like doing nothing. It's equivalent to doing nothing, except that we do something that's similar to vapor up. We hand them a jar. So we take care of the handing them a jar and telling to put it on themselves aspect. And which one they should get should be assigned randomly. For the same reason as before, we don't want to bias the result in any way. We need that to be done randomly. And that is called randomization or random assignment. Which treatment they get should be given to them in a random manner. At this time, let's take an aside, and let me talk about the two terms with the word random in it that I've said in this video. One term is random selection, and the other term is random assignment, and they mean two different things. Random selection is when you take a population and you randomly select who gets to be in your sample. That's random selection. Random assignment, also called randomization, is when you already have your sample and you're going to assign them either a placebo or vapor up. That's random assignment. I also have a video about that, so check out the link above. So we do our random assignment and we have two groups, one group with vapor up, and that's called the experimental group. The group with the placebo is called the control group. Right, so far so good. What's wrong with this picture? If we give the people in the experimental group that jar of vapor up, and we give people in the control group that jar of placebo, what do you think happens? Yeah, the people getting a placebo, they're going to look at it and say, what on earth is this? Why should I even bother? It says placebo right here. So yeah, don't tell them that they're getting vapor up in placebo. Hide the jar. On one of them, put the number 1 on it. On the other, put the number 2 on it. And don't tell them which is which. That's called a blind experiment. A blind experiment is when we don't let the subjects know which treatment they're getting. Okay? They see a number 1 or a treatment A, but they don't know if it's a placebo or vapor. That is good, but it's still not blind enough. There's a human being administering the treatment. That human being may, through facial expression or body language or something, betray to the subjects what it is they're getting. Right? If the nurse that's handing out the jars know that number 1 stands for vapor up and number 2 stands for placebo, she may somehow inadvertently let the subjects know. So we shouldn't tell her either. Don't tell the person administering the treatments which is which. Just ask them to keep track of, like, this person gets jar number 1, that other person gets jar number 2. That's all. When the subjects don't know what they're getting and the person administering the treatments doesn't know what they're getting either, that's called double blind. And for good control, you want double blind. All right, so now we got everything set up. We're almost ready to go. When one of our colleagues, the smart one, raises her hand and asks, what if gender may affect our results? What if vapor works differently on one gender versus another? I guess we better divide people by gender then. Make sure that all the people with the same gender over here and the others are over there, and try them out separately. Yeah. Okay, thank you for your input. And then the colleague says, I'm not done yet. What about age and ethnicity? What if those also affect our results? We don't know if it will, but it feels like it probably will. You know what? Good point. Let's separate them by age and by ethnicity as well. So those 3 things that our colleague brought up, gender, age, and ethnicity, they're called blocking variables. A blocking variable is a new variable, an outside variable other than the explanatory and the response that we think may affect the results. And what we do with the blocking variable is to block. The process of blocking means we take the sample and we separate them out. We separate the samples into blocks, where within each block, the subjects in each block will have the same blocking variable values. So in block number 1, they all have the same gender, age, and ethnicity. In block number 2, they also have the same gender, age, and ethnicity, may be different from block number 1. And then in block number 3, within that, they have the same gender, age, and ethnicity, but will be different from block 2 and will be different from block 1, okay, etc. You do as many blocks as is necessary so that all the genders, age, ethnicity combinations are accounted for. And then within each block, you randomize. You randomly assign to the experimental group or the control group. So now we're done setting up. We're ready to collect data. How am I confident that we're done setting up? Because we have the separation of experimental group versus control group. That way I can separate out the effect of vapor up in the experimental group from the placebo effect in the control group. So I have that taken care of. And then the fact that I did blocking That means I can separate out the effect of all the different genders, ages, and ethnicities because they're all in separate blocks. So I can tell the difference from here to there. So that's how I know I'm ready. Let me summarize. You need to start with the preparatory step where you write the research question, and from there you identify the explanatory variables, the response variables, and any blocking variables. You can save the blocking variables for later, but might as well do it at the beginning. In step 1, you need to do sampling. When you do sampling, make sure your sample size is large and make sure there's randomness. Step 2 is blocking. Because you already identified what the blocking variables are, now all you need to do is separate your sample out to different blocks based on the different values of the different blocking variables. Step 3, randomization. Within each block, you randomize into experimental groups and a control group. Make sure it's double blind. And at that point, you're basically done with experiment design. You just need to start collecting data. So you need to say 1 or 2 sentences about collecting the data. Let me repeat the process as a diagram. You start out with a population or population of interest. In the sampling step, you select a sample. Sampling should be random. Based on the blocking variables, you separate the sample into blocks. Each block should have the same values of the blocking variables. And then you do your randomization or random assignments. Each block is broken by randomness into control group and experimental groups. Remember that randomization comes after blocking. And now you're ready. Start collecting the data. This is a standard process of experiments in a statistics class. We teach it like this because it satisfies the 4 conditions of a good experiment design. What are the conditions or criteria of a good experiment design? Number 1, you need to have control. You need to have placebo versus experimental, and you need to have double blind. Number 2, you need to have replication. Replication means repetition. You need to be able to repeat the experiment. There are 2 ways you can talk about repeating. In a stats class, we talk more about repeating an experiment within that sample. So you want to have a large sample size so that the experiment is done multiple times within that sample. Now, in real life, there are a lot of times when people do replication by repeating the same experiment, like the whole thing. Repeating the whole thing all over again. This is done a lot in chemistry and physics. When someone makes a huge breakthrough in chemistry or physics, someone in another lab at another university always try to recreate that experiment under that exact same circumstances to see if they still get the same results. If they cannot get the same result, it casts doubt on the original experiment. Third criterion or third condition is blocking. Make sure you separate out by whatever variables that may affect the results. That way, you won't be confused or misled by the effects of different blocking variables. And number 4 is randomization. The assignments of placebo versus other treatments need to be random. Let's go back to our example. Pretend it's a test question, and I'll show you how to write the answer. You want to test whether using VaporUp over 2 days will relieve stomachache. Gender, age, and ethnicity may affect the results. Design an experiment using a sample size of 200. First, go through a preparatory step. You can do this on scratch paper, but I would just go ahead and write it in the test paper because why not, right? You want to write the research question and any variables. explanatory, response, and blocking. And I like to write my research question as, does this lead to that? That way I can tell explanatory and response right away. Research question, does vapor abuse over 2 days lead to stomachache relief? Explanatory variable, vapor abuse. Response variable, stomachache relief. Blocking variables is right there in the question, gender, age, and ethnicity. I have all my information, I'm ready to go. Step 1 is to do sampling. I want a sample size of 200. And one of the things about a classroom question is that you can assume you can get hold of any information you want. Let's just get ourselves a list. And now let's make sure we have random selection. There we go. If you work with numbers, you can always use a random number generator and get a random list. Now, I have to use the word unique right here because a random number generator is kind of like rolling a die, right? The same number can come up twice. So I have to use the word unique right there to say that if the same number comes up again, just don't use it. Start generating other numbers. There's a lot of people with temptation to just stop here, but you have to pretend that you're talking to someone who doesn't quite know statistics like you do. Imagine that you're talking to an intern. The intern may be smart, but they don't know everything you do. So you have to tell them what to do with these 200 unique numbers. Right, so now you have your sampling step. Step 2, we want to do blocking. We know what the blocking variables are. They're gender, age, and ethnicity. So we have to tell the intern how to separate the sample by gender, age, and ethnicity. That probably means you also need to tell the intern how to separate them. So for example, for age, if you separate them by every single numerical value, it may be too much. So you want to group them more broadly. Under 21, between 21 and 39. Yeah, especially in the US, 21 is a separate drinker from non-drinkers. 21 is a good number to separate people. 65 is the usual retirement age. So 65 is a good number to separate people. And then in between, because a huge gap, just pick a nice round number. I pick 40 to separate them, right? That's age. Gender, let's say male, female, others. Now I realize that could be controversial to some people. So if you want to just use male and female, go ahead and do that. And ethnicity, group them however makes sense to you. And right here, I just put down etc. And you also have to explain to the intern what blocking means, right? There we go. Step 3 is to randomize, meaning from within each block, you want to separate out the vapor group from the placebo group. Randomization also includes double blind. So this is a step where you need to write a lot of things to the intern to make sure that everything is done correctly. So let's deal with double blind part first. So far, all I've done is basically say what a placebo is. And then just label them differently. Don't tell the subjects and don't tell the nurse administering the test. All of this is to ensure double blind. Having had double blind, now I have to make sure I have random within each block. So I want to make sure each block has half vapor up and half placebo. Here's a process that's kind of like pretty standard. So ensure random within blocks. This is a step. And again, it uses random number generator. Within each block, number the people. And now let's use a random number generator to randomize them. To randomly scramble the block. Now they're all in different orders. Repeat for all blocks. So what I have right now is one block that's all random, and another block that's also all random, and then another block that's random. All these blocks are random. And that way, I can start handing out the jars in alternating order. Vapor up and placebo in alternating order, and it will be random because the jars are not random, but the recipients are random. Overall, I do have random. Then each group will have the jars handed out randomly, each block, with about half of each. So I have my randomization that's nicely, evenly divided. Scrambling the list and then assigning the treatments in order is a standard way of answering an exam question on randomizing within a block. All right, so at this point, we're actually done with the experiment design. We just need 1 or 2 sentences about collecting the data. There we go. That's it. That's the end of the exam answer. Having written the answer, let's double check. Did we meet the conditions for good experiment design? Is there control? Is there replication? Is there blocking? Is there randomization? Control means double blind, placebo versus experimental. Yes. We had control. We went through all this work to make sure that within each block, there's about half of people with jar 1 and half with jar 2. So yes. Is there replication? Replication means either a large sample or you're repeating the whole experiment all over again. We didn't repeat the whole experiment all over again. We only did one experiment with 200 people. We'll go for that one. Yes. Sample size of 200 is large. It's objectively large, and also in every stats exam question, whatever sample size they give you, just assume it's large. I mean, unless it's obviously not large, like single digits or something, right? Otherwise, 30 people, 50 people, any of that, you can just assume that it's large enough for the purposes of statistics. Number 3, is there blocking? Yes, we had a whole step that's actually called blocking. We separated people out by gender, age, and ethnicity. Is there randomization? Yes, we had 2 whole slides on randomization. So yes, we had all 4 conditions of good experiment design. We weren't even like trying, okay? We just followed the process and automatically we get all of these conditions. All right, that's the process of experiment design. And I'm putting this diagram up here again for reference and as a summary. Any questions? Ask in the comments section and I'll answer them. Share, like, and subscribe for more contents. And thanks for watching. Bye.